Welcome to Decoding Superhuman. This show is a deep dive into obsessions with performance and how to improve the human experience. Twice a week, I explore the latest science, technology, and tactics with experts in various fields of human optimization. I'm your host, Boomer Anderson. Enjoy the journey. So when you sit down with one of the leading figureheads in the field of aging, what do you ask them? I recently had the chance to catch up with Dr. Aubrey de Grey at the Health Optimization Summit in London. If you're unfamiliar with Dr. de Grey, let me catch you up real quick. Dr. de Grey is an author, biomedical gerontologist, and the chief science officer of the SENS Research Foundation. I was grateful for the time he gave me, and we had a very quick conversation around many different areas. We talked about Aubrey's 7 pillars of aging, the research that he's currently doing, what he thinks about things like biological age and those calculations, but also the impact of growth hormone on biological age. And finally, I round out by asking him more of a personal question. How does one go from being a computer scientist to a gerontologist? You can find the show notes for this one at decodingsuperhuman.com/Aubrey. Enjoy my episode with the magnificent Aubrey de Grey. Dr. de Grey, thank you for taking the time.
My pleasure. Thank you for having me.
So we're here at the Health Optimization Summit in London. You just gave this fantastic talk, and I have to ask the question, where are we in the battle against aging?
Well, of course, when you're in the middle of a long process, it's always quite hard to see where the end is going to be. But what I think I can say more concretely is that we are moving much faster than we were even a few years ago. Mm-hmm. The areas of aging that I view as the most difficult ones, the technically hardest ones, even they are now moving forward very, very respectably. And of course, a large part of the reason for that is that the private sector has started to get involved with the creation of very large numbers of startup companies working on all aspects of damage repair, and of course funded by every kind of funder you can imagine, from individual angel investors through to VC companies. It's very exciting, but I never want to be overly confident. I'm still, when people ask me for timeframes for when we're really going to reach longevity escape velocity, when we're going to essentially have aging under complete medical control, I still give an answer in terms of probabilities. Mm-hmm. So I think that we have a 50-50 chance of getting there within 17 years from now. That's my current number. It was 25 years.
I have to ask, why 17 if you don't?
Well, it's really just a case of aggregating a lot of different uncertainties in my mind. So I look at all of the various types of damage and the stage that we're at in developing ways to repair those types of damage. I ask, how long is it going to be before we get to clinical trials? How long is it going to be that those clinical trials take before they succeed? Again, all of this is estimates, right? Mm-hmm. And then, of course, the really big thing that comes at the end is combining these therapies, giving the multiple different therapies to the same people at the same time, which again is another whole clinical process. Mm-hmm. So, adding all of that up, that's 17 is the number I get right now.
So let's go a little bit into, I guess, the classifying aging aspects or the different elements of aging. You've boiled it down to 7. Now we've seen 9, we've seen different numbers from other people. Do you mind just walking through just quickly those 7 aspects?
Sure, yeah. And actually, first of all, before I do that, let me explain the reason why different people come up with different answers. Mm-hmm. It's not that they think that things are, some people think that something is important and someone else doesn't think it's important. Well, sometimes it's actually, some people leave things out. Really, it's just a case of the motivation. So my classification is driven by the need to pair up each type of damage with a corresponding generic therapy. Mm-hmm. So one of my categories is loss of cells, and that is treated by stem cell therapy, where you put cells in that will divide and replace the cells that the body is not replacing on its own. Things like that. But yes, so the 7 categories that I have, first of all, there are 3 that have to do with how many cells we have of a particular type. So I just mentioned stem cells. You need those because some cells, they die and they're not automatically replaced by cell division, so the number of cells goes down and down, and eventually you don't have enough for the affected tissue to do its job. Then the other 2 types of cell number problem are the opposite, namely having too many cells of a bad type. And one way you can have that is if the cells are dividing when they're not supposed to. So, of course, that's more or less the definition of cancer. And the other way is if cells are not dying when they are supposed to. So the big, very high-profile subset of that category called senescent cells, which have been in the news a lot over the past few years because people have developed drugs that can selectively kill those cells. Then the other 4 types of damage are not at the level of cell number, but rather at the level of molecular changes. So 2 of them are to do with waste products, just waste products that are accumulating because the body does not have the ability to break them down or to excrete them. And I have 2 categories because I distinguish waste products that accumulate inside cells as opposed to outside cells. And the reason for that, again, is driven by the corresponding therapies. Stuff that's outside cells, turns out that all you need to do is get it inside the cell and it's toast because it's intrinsically not very difficult to break down. It's just it's in the wrong place. So the approach that seems to be working for that is an immunotherapy approach. Then for stuff that's inside cells and it's accumulating anyway because it's intrinsically really hard to break down, our approach has been to identify other species, especially bacteria, that are able to break down these substances and introduce the relevant genes from the bacteria into human cells. And that's worked out quite nicely.
Is that the advanced glycation end products?
No, that's another one. So those are just waste products. Advanced glycation end products are important when they form cross-links, actual bonds between molecules that have a purpose and that we don't want to break down. And that, again, happens outside the cell, especially in the lattice of proteins called the extracellular matrix. The reason it happens there is because the extracellular matrix has very low, if any, turnover. So the proteins are laid down once and they just sit there forever. And that means that they can gradually accumulate these molecular changes. Yes, so we need to break those links because what the links do as they accumulate is they stiffen tissue. They cause the tissue to lose its elasticity. And that's a big contributor to hypertension in the elderly, as well as more cosmetic things like wrinkles. So I've almost done, actually. The only other type of damage I haven't yet listed is accumulation of mutations in the mitochondrial DNA. So the mitochondria are these very important parts of the cell that do the chemistry of breathing. They combine oxygen with nutrients in order to extract energy from those nutrients. And mitochondria have their own DNA. It's a very bad place for DNA to be because there's lots of toxic molecules, free radicals that are nearby. And so we're putting backup copies of that DNA into the nucleus, into the regular chromosomes. We have to modify the DNA so that it still works even though it's in the wrong place, and we've more or less cracked how to do that.
Can we, just going back to advanced glycation end products, because you had a paper released in May, I believe, around that, and correct me if I'm wrong here, but is there anything that we can do in terms of lifestyle modifications around these things? Because you see advanced glycation end products and things like olive oil, butter, etc.
Right. So AGEs in our food, some people have suggested that they may actually have a contribution. But actually, I think the evidence is pretty weak on that. Essentially, these are cross-links between proteins. And of course, proteins get broken down in the gut before the amino acids get absorbed. And so, these links are not going to become structural when they get into the body, even if they get in at all. However, there are certainly lifestyle and dietary things that one can do to minimize the accumulation of AGEs in the extracellular matrix, because AGEs are formed by the chemical reaction of proteins with sugar. And of course, control of how much sugar you have in the circulation is very much a lifestyle thing. It's to do with insulin resistance. Is to do with how much sugar you have and also, how well you metabolize it.
Mm-hmm. So going back to just broader themes around lifestyle modifications, and I know you mentioned in your talk that you deal a lot on the biotechnology side. Are there lifestyle factors, or which lifestyle factors do you see contribute the most to aging?
So really, the one you've just mentioned, the contribution of sugar intake and sugar control to advanced glycation end product accumulation, that is the only really big one. Most lifestyle and dietary things have only really a very small contribution to the rate at which we accumulate different types of damage. Mm-hmm. Of course, you can have a really bad diet that shortens your life because it's short of micronutrients, for example. So it's very important, certainly, to have a reasonably balanced, varied diet. But beyond that, basically just doing what your mother told you to and not getting seriously overweight and not smoking, that's pretty much it. The other stuff that we can do on top of that gives really only a very modest increase, if any, in how long we can stay healthy and therefore how long we can live. And on top of that, of course, we have to remember that each individual is different. Yeah. So that there's no, as Dave Asprey was saying this morning in response to one of the questions, there's no one-size-fits-all for diet and lifestyle.
Mm-hmm. In terms of just one of the things you didn't mention, I'm curious about your thoughts of sleep and sleep deprivation, the contribution of that to aging.
Yeah, it's important. Certainly getting an insufficient amount of sleep is bad for the body in all manner of different ways, hormonally, psychologically. So yes, it can make a contribution. But again, how much sleep is enough? It varies from one person to the next.
Mm-hmm. Now, looking at, and we're going to jump around here a little bit, guys, but Nature recently, there was a paper that came out around human growth hormone, metformin, DHEA. Love your opinions on that in terms of how they use Horvath's clock as a measurement. So first, I would like your opinion on biological age measures in general and what you think about those. And then secondly, about the study.
So biological age measures in general, clocks and stuff, this has been a big deal lately, especially because Steve Horvath and a number of other groups developed really good ways to define one's age. It started out being simply a way to correlate the epigenetic state of a cell with one's chronological age. But that in and of itself is no use at all, of course, because we've already got birth certificates, right? But the way that Steve likes to say it is the noise is the signal. In other words, the deviation from that correlation is what's interesting and what you can actually use as a measure of the efficacy of an anti-aging therapy, for example. So yes, I certainly believe that these clocks are very important, and they won't ever do the whole job. I think it's going to continue to be very important to use physiological measures of of biological age as well, like the kind of things that have been around for a while where they measure like 150 different things in your blood and so on. This is all, the best clocks are going to be ones that are highly composite and combine all of these things. So that's very important, and progress is continuing at a rapid rate to improve the accuracy of these clocks.
So right now, would Horvath's clock be the best of breed, or is there some other one that you like a little bit more?
Well, even Horvath, these are all moving targets. So Horvath himself is obviously a researcher, and he's improving his own clock all the time. And there are a number of other researchers doing the same thing. It's a very, very vibrant field. You can't really say which is best at this point. All right, so this particular study, it actually didn't come out in Nature, it came out in Aging Cell, which is a Nature journal. Just in case your audience gets confused. So it was led by a guy named Greg Fay, who has been fascinated by thymic shrinkage, thymic atrophy, for a very long time. He's actually better known in the longevity world for his work in cryobiology. He's a very, very world-leading cryobiologist. But this is something he's been doing on the side. And eventually he was able to get this clinical trial together. It was a small trial, only 9 people, and no control arm, only open label. But he had come to the conclusion, based on self-experimentation many years ago, that human growth hormone had the potential to allow the thymus to regrow. And he refined that idea to incorporate DHEA and metformin because of evidence that human growth hormone on its own may accelerate diabetic complications in the elderly. So he wanted to counteract that. And so he gave these 9 people this stuff. And as you say, the trial seems to have been rather successful. First, in terms of the actual regrowth of the thymus, does seem to have happened. And there was also, demonstration of functional efficacy in this in terms of, improved population of naive T cells, which is what the thymus makes.
Mm-hmm.
And on top of all that, as you say, there was a reversal of the biological age as measured by Horvath's clock. Now, I don't want to read too much into this because, of course, it depends what cell type you look at. Some of the cells that were being looked at may have had their clock somehow, reset by virtue of changes to the actual cell types.
Mm-hmm.
And there's lots more detail that could be done in a bigger study, a better funded study, obviously. But as a starting point, to motivate the pursuit of further work in this area, I really think the study was very valuable.
Mm-hmm. Perhaps taking a step back at just broader aging questions in general, why, I guess not why do we have aging, but why hasn't evolution allowed us to delay aging? You don't have time for that 45-minute jog. Frankly, who jogs anymore? You need something fast, efficient, and leaves you wanting more. My favorite tool for this, and I love it, is the Carol. She is a life-changing bike that provides you all the endurance you need in 2 20-second bursts. Yes, you heard that correct. That's 40 seconds of max effort. Including the warm-up and cool-downs, you get a kick-ass workout in 8 minutes and 40 seconds. How? The Carol is a resistance bike powered by artificial intelligence, which personalizes and optimizes the resistance so you hit your maximum intensity levels and maximize glycogen depletion every single time. The proof is really in the pudding. Carol's effectiveness was independently verified by the American Council on Exercise. I gave the Carol bike a spin at Health Optimization Summit in London this year, and she kicked my ass so much that I had to get one. Check out Carol at carolfitai.com. That's CAROLFITAI.com. If you have limited time and want a kick-ass workout, which basically everyone that listens to this show does, use the code DECODING150 for a $150 discount. Head over to carolfitai.com to secure yours. So this is a well-understood thing. It was first really described by a British immunologist, in fact, named Peter Medawar, back in the 1950s. And now there is pretty much universal agreement on this among gerontologists. Essentially, it's not that evolution wants us to age. It's that evolution doesn't not want us to age badly enough. Evolution doesn't care. One of my colleagues, Len Hayflick, described it very well. He said that aging is a consequence of evolutionary neglect rather than evolutionary intent. So what it all adds up to is that the accumulation of damage in the body, which is what aging is, happens as a result of gaps in our arsenal of machinery to repair damage as it comes into existence. So species that live longer just have fewer gaps, smaller gaps. They have a more comprehensive, automatic, built-in damage repair arsenal. So the thing is, in order to have a more comprehensive damage repair arsenal, you need more machinery. Right? And that means more genes. And that means more opportunity for mutations to come along and inactivate those genes from one generation to the next. So it's harder work to, you need more selective pressure, so to speak. And that selective pressure comes from what's called extrinsic mortality. In other words, causes of death that do not have to do with how long ago one was born. So species that are lower down the food chain, that have a high rate of mortality from predation, they also tend to have a more rapid aging because there's no point in having more machinery. There's no selective pressure to maintain that machinery. And conversely, in the other direction, if you're not being eaten very much, then you're likely to evolve
machinery to allow you to live longer, because then you're going to have more time to have more offspring.
Mm-hmm. One of the things I found fascinating about your presentation, you had this slide where you had, I believe it was 4 components or 4 columns. And then you said in column 3, there was Alzheimer's, cancer, and cardiovascular disease were components of aging. Do you mind just explaining that a little bit? Because if you look at leading causes of death, you have basically most of them right there.
Right. I mean, what is a cause of death? Mm-hmm. The thing is, that it's a terminology thing, but it's a really important terminology thing because it can be misleading if you get it wrong. These causes of death, cancers, Alzheimer's, people call those things diseases. But what does that mean? That means that it has the connotation that we can cure them, mm-hmm. which we can't because they're parts of aging. And what do I mean by saying they're parts of aging? Simply that they don't affect young people. They affect older people. I mean, how can something be a health problem late in life but not early in life? It has to be part of aging, right? Mm-hmm. It has to be the later stages of something that has been accumulating throughout life but was initially harmless because there wasn't enough of it. Mm-hmm. So, that's the definition of aging in the first place.
I don't want to use the term longevity based on what we just discussed or I saw you present, but looking at aging as more of just a question, hypothetically, you're talking additional therapies. Is aging going to be a rich person's agenda?
People are often very worried about the idea that these therapies, when they come along, they're going to be really expensive and only wealthy people are going to be able to access them. But we don't have to worry about that at all. Mm-hmm. Today, of course, we do have exactly that problem, that the high-tech, really expensive therapies for the elderly, they are expensive, and even in countries with socialized medicine, they are limited by ability to pay. But the reason that society allows that to happen is because those therapies basically don't work. Mm-hmm. They, if you're lucky, they'll postpone the health problem by a little bit and maybe extend the time that you live in a poor state of health before you die. This is not really particularly attractive. And economically, it from the point of view of the government, it is money down the drain. The people who are getting these therapies don't work because they're sick. So it's just money being spent with no real economic gain. But we're in a completely different situation if we look at therapies that do work. Because there, we're keeping people who were born a long time ago able-bodied and able to continue to contribute wealth to society. Mm-hmm. And also, of course, we're not having to spend the money on the people to keep them alive in a poor state of health. Prevention is always better than cure. Mm-hmm. Plus, other things. The kids of the elderly are going to be more productive because they're not having to look after their sick parents. So economically, the benefits will be absolutely astronomical. And that will mean that whatever the type of government that's involved, whether it's, a country that really doesn't like taxation like the US, whether or not it's a democracy, China's the same. All of these countries will be economically benefiting from front-loading the investment to ensure that everybody who is old enough to need these therapies can actually access them irrespective of ability to pay. Countries that doesn't do that will go bankrupt.
Mm-hmm. What's your focus for the next 6 months to a year? What if you're looking at these 7 pillars and all of them need to eventually integrate into each other? What is your key next focus?
Well, we don't really have that kind of way of thinking of how we proceed. We understand that all of these types of damage are equally important in the sense that each one of them can kill us more or less on schedule, right? However well we fix all the others. Therefore, we determine our priorities based on how much work other people are doing in these areas, so as to make sure that nothing gets left behind and that the ones that are furthest behind catch up. But beyond that, we don't think in short time frames like 6 months. We just, we pound away for as long as it takes to get therapies or to get research areas to a point that we can spin them out into startup companies or other companies come along doing the same things.
Mm-hmm. One question before I transition to the final 6. Based on my reading of your bio, you started in computer science.
That's right.
How does one go from computer science to gerontology?
There's no one answer to that. I mean, it involved a huge amount of luck. Basically, what happened was, I was a perfectly self-respecting computer scientist and working on artificial intelligence research. And then I met and married a biologist. She was a lot older than me. She was already a full professor in the US at UC San Diego. She was actually in England on sabbatical. Mm-hmm. And so, anyway, over the next couple of years, I kind of accidentally learned a lot of biology over the dinner table, just by, asking her what she did today. But then gradually it began to dawn on me that, that we were never talking about aging. And I started asking questions, and it turned out she just wasn't interested in aging. For sure, it wasn't very important. And it turned out other biologists that I was meeting thought the same. I would say, aging is bad. Aging, why aren't you interested in it? They would say, well, it's just decay, isn't it? What fundamental truths of the universe are you going to find out by studying decay? And I would say, well, sure, I understand that, but hang on. I mean, it's bad for you. And they would say, well, that's not my problem. And I would say, it kind of is. and so eventually I came to terms with this. I decided, well, okay, nobody's working on this, so I'd better switch fields, because the problem, I was working in artificial intelligence also for humanitarian reasons. I felt, work is a big problem. The fact that we have to spend so much of our time doing stuff that we wouldn't be doing unless we were being paid for it. Mm-hmm. So let's have more automation, right? Mm-hmm. But aging is clearly a much bigger problem than that. So, and I had this extremely undemanding job. I was working in a bioinformatics project at the University of Cambridge, which gave me a lot of spare time. I had actually taken the job for that reason.
So you could have time to explore other interests?
That's right. It wasn't an interesting job at all, but it was allowing me to do my artificial intelligence research without funding in my spare time. So all I had to do was to repurpose my spare time. And of course I had, because I was at the university, I had access to all the libraries. And this was in the days when, in order to actually read people's work, you would actually go to a physical library and read a physical piece of paper. Mm-hmm. So that was very helpful, and it allowed me to pay my way to go to conferences and get to know people and so on. So it was easy for me, but it's not the kind of path that most people would be able to follow.
What resources would you recommend if somebody wanted to unpeel the layers of the onion of aging and just really sink their head into this? What are your favorite resources around it?
Well, of course, I wrote this book a decade ago. It's still very good, I think. It's written for a general audience. Mm-hmm. I mean, it doesn't cut any corners. It's very thorough. So even a seasoned biologist would not read it in one sitting. Mm-hmm. But equally, it doesn't rely on knowledge of biological jargon or anything. So, it's the place I would start.
Dr. de Grey, I want to transition to the final 6 questions that I ask every guest.
All right.
And what's your favorite piece of technology that you've purchased for yourself in the past year?
Wow. Have I, in fact, purchased any piece of technology in the past year?
I've had David Allen on the show, and he actually didn't purchase anything. And it was kind of interesting to hear that just, a guy... You just don't.
Yeah, I can't actually think of anything. I mean, I get given stuff a lot.
Okay. Any of those gifted that you remember that being?
No, it tends to be boring stuff. Water bottles and power strips, things like that.
Okay. What book has significantly impacted your life and the ability, or for you to show up and perform in it?
I don't read very much. Even when I was younger, I would not really read books that were inspiring me. Mm-hmm. Music would inspire me more, I guess.
Mm-hmm. Okay, then that begs the question: favorite types of music?
Sure. Well, okay. So when I was a teenager, I would listen to the kind of things that you would listen to as a teenager when it was in the 1970s. Pink Floyd, Led Zeppelin.
Oh, excellent. We could talk about music all day long then.
Yeah. No, I guess I was inspired by some of that. Mm-hmm. Wish You Were Here was a song that inspired a lot of people. I guess I could count that one.
That is a fantastic tune, actually. What's your top trick for enhancing your focus?
That's a really interesting one, because when I started working on aging, I had this other job, this day job on this bioinformatics project. Mm-hmm. I was switching between the two a lot. And I found that I had a lot of downtime. It was very hard to actually switch focus and get get properly into the other thing.
Mm-hmm.
But somehow or other, I managed to work my way out of that, and so that I could switch really easily and really quickly. And I have asked myself a lot, what trick did I learn? But I could never put my finger on it. I just basically...
Because task switching is a known distraction for people, right?
Yeah, I just got really good at it.
Mm-hmm.
But I never figured out how I got good at it.
Mm-hmm. So overall, you're able to switch tasks pretty easily.
In fact, more than that, I would say actually I do better if I switch quite often than if I focus for a long, long period on one thing.
Mm-hmm. Sounds like some traders listening to this may relate to that as well.
Maybe.
How do you unwind?
I have a hot tub.
That's
I
excellent.
stare at the sky.
Oh, beautiful. And in California, I imagine that's absolutely gorgeous.
Exactly. I have extraordinarily good fortune to have a house in the mountains, complete paradise, extraordinarily quiet and tranquil and peaceful, and the hot tub is the cherry on the cake. Does the quiet and being out in the mountains help your thinking at all around? Enormously.
Okay.
Yeah.
I'm a person who loves to get out in the nature, but I live in a city, so it's a little bit difficult sometimes. Favorite place to go on vacation or holiday? I actually like staycations. I prefer to actually, because first of all, because of the nature of my work, I don't really like to be off the grid. I know I'm constantly beset by the knowledge of how much backlog I'll have when I get back on the grid. Mm-hmm. So I prefer to keep my inbox under control. But that means that if I'm at home and I don't have to worry about where the next restaurant is, or I'm just I've got control over my environment, then that's the most peaceful and most vacation-like situation for me. Dr. de Grey, where can people find out more about you? We have a website. It's called SENS.org. And it's got everything for everybody, really. We have a very wide range of material there for every kind of audience, from complete newcomers all the way up to experts, both in our own activities and news from around the world. It talks about all of the research that we're doing and all of the other efforts that we have. And of course, there's a nice big friendly donate button. I was going to say, there is room to donate. And I think you guys accept cryptocurrencies now, too. We certainly do. We accept every cryptocurrency that is traded at Coinbase, which is, I think, about 10 currencies now. Mm-hmm. Dr. de Grey, thank you so much for taking the time. Amazing presentation. I really appreciate you taking the time to meet with me today. Thank you very much for having me. Wow. Aubrey is one smart guy. I especially enjoyed the conversation around AGEs, or advanced glycation end products. And it's really incredible and generous of him just to take the time to sit down with me. You can find the show notes for this one at decodingsuperhuman.com/Aubrey. And if you enjoyed it, share it on all the social medias. Be sure to tag Decoding Superhuman, because I'd love to hear from you guys. If you have any comments on the episode, podcast@decodingsuperhuman.com is where you can reach me. And if you enjoy this show and want to see it just continue on, head over to iTunes and leave a review. I read all of them, and you can expect that we may be doing a little bit of a giveaway sometime soon. Thank you, Superhumans. Have an absolutely epic day.